You might be asking yourself a little bit about why would I want to galvanize a bridge that's a temporary structure? Because most people understand or know that galvanizing is commonly done to extend the life of a structure. But I hope as we go through today, you'll see some reasons why that might be beneficial even in temporary bridge structure. But before I get started, I have to make a quick comment about Glenn and Michael's discussion of the zip line installation of the bridge, which was pretty impressive. One of the other things that I'm not going to show today, but we had a bridge in Vancouver, I believe it was, that was put in, that was helicoptered in the pieces of the pedestrian bridge. So a lot of creative ways, I guess, to get a bridge into place if needed. Just a little bit about the American Galvanizers Association, if you're not familiar. We are a trade organization that has been around since 1933, and we just kind of provide a unified voice and expertise in after fabrication hot dip galvanizing. So our primary mission is really just education and guidance for specifiers, for architects, engineers, and other folks who are looking to use galvanized steel in their projects, and then provide some resources for our members when they join the association. Here's kind of the goal of my 20 minutes or so is just to understand a little bit about galvanizing, to know why specifiers might choose to use galvanized steel, and then just show you some case studies of temporary bridge structures to understand why even in a temporary bridge galvanizing might be beneficial. So to start, I just want to make sure that we all are familiar and understand the hot dip galvanizing process and what we're talking about here. So this is just a quick graphic that shows what the galvanizing process looks like. It starts with surface preparation that's done within the galvanizing or the galvanizers facility, excuse me. There's three major steps in that surface preparation. Degreasing, which is going to take off organic compounds. Pickling, which is really the primary cleaning mechanism. This is a mild acidic solution that's going to take off all mill scale and oxides. Basically, when it comes out of that bath, it's at a near white metal clean. And then the final step of the surface prep is just a flux solution, which will basically do any final mild cleaning of contaminants on the surface since it was removed from the pickling bath. And more importantly, put a protective layer on the surface so no contaminants will basically form before going into the galvanizing bath itself. A little bit about the galvanizing bath. It's heated to about 830 degrees Fahrenheit. It's required to be at least 98% pure zinc. The 2% of additives, there are limits within this, but it is to the galvanizer's discretion. The most common that you'll see are aluminum, bismuth, and nickel. And these help with things like the fluidity of the zinc, the shine of the coating, and controlling the coating thickness. Basically, while it's in the galvanizing bath, it's going to stay in there until it reaches bath temperature. Typically about 5 to 7 minutes. The kettle operator would know when the steel has reached the bath temperature because the bubbling on the surface would dissipate. And while it's in the kettle, there's going to be a metallurgical reaction between the iron and the steel and the zinc in the kettle to form the galvanized coating. And we'll talk a little bit more about that as we go forward. So what are some of the benefits of using hot dip galvanized steel in bridge structures? We're going to talk about kind of the 5 big ones or 6 big ones here, but I think we'll try to relate those into the temporary bridge structure as well. So as we talked about at the beginning, the biggest reason or the most common reason that hot dip galvanized steel is chosen is for its corrosion protection. And it really provides 3 levels of protection. It provides that basic barrier protection that basically any coating used would provide by isolating the steel from the environment. But more importantly, it provides cathodic protection, which basically means that the zinc is going to sacrificially corrode to protect the underlying steel. So basically, as long as there is zinc on the piece, it's going to corrode and prevent the steel below it from corroding, excuse me. But the real longevity of galvanizing comes into play with what's known as the zinc patina. And this is something that develops naturally as galvanized steel is exposed to wet and dry cycles in the environment. It produces a series of byproducts on the surface, zinc oxide, zinc hydroxide, and zinc carbonate, which will slow down the overall corrosion rate to about 1/30th the rate of steel in the same environment. So here's our first case study. This is an example of a galvanized steel temporary structure that was put up in Chicago, Illinois, just a couple years ago. This is a US bridge structure, and they put it in to replace a 1914 bridge that needed to be removed. Initially, it was put in as a temporary structure. In fact, they were able to deconstruct the old bridge and reconstruct this temporary modular structure within 3 months of the start. So all of that happened in a quick turnaround time. And now that the bridge is there and it's performing well and looks nice, they're actually discussing leaving this as a permanent structure. But the good thing about using galvanized steel on this particular project is that it provides that flexibility. If they choose to only leave this bridge in place for 5 years, it's ready for that challenge. If they decide to leave this bridge in place for 100 years, like the previous structure, it's also ready for that challenge. Another benefit of hot dip galvanizing is its durability. And there's kind of a few different areas within durability that really come into play. The first is its abrasion resistance. And this has to do with the fact that the galvanized coating is not just a surface coating on top of the steel, but basically becomes a part of the steel and is intermeshed with the iron of the steel. And this photomicrograph is showing that basically the layers of the galvanized coating are a combination of zinc and iron. So we're not just sitting on top, but we're now intermeshed with the steel itself. And that provides great bond strength, and hardness of the coating is actually harder than the steel itself. So very difficult to damage, very difficult to hurt the coating or cause any sort of damage that would allow the underlying steel to be exposed. This is an example a little bit different than the first one. This bridge in Ohio was, again, a structure that had been in place for over 100 years, since 1913. They had to close it in 2010 because there was some corrosion concerns or structural concerns. And so in 2015, they took down the bridge, deconstructed the existing bridge, and hot dip galvanized it and put it back into place. They did make a few engineering changes because of differences in code, but a lot of the 100-year-old steel in the original bridge was dipped and reused in the galvanized or the new galvanized structure. So they didn't really have to replace the bridge. They simply reused the existing structure and added in the support that was needed to open this back up and preserve the historical significance of the former bridge. Another part of hot dip galvanizing's durability that's important to understand is that it provides uniform protection and complete coverage. And what do I mean by that? Well, basically, hot dip galvanized coating grows perpendicular to every surface of the steel. And so that means that any of the corners or edges will have the same thickness as flat surfaces. And any interior areas, if a hollow structure or threads of a coating, are going to be fully coated. So there's really no weak point for corrosion to begin or to attack the bridge. This is another great example of a temporary bridge that's likely to become a permanent structure, but all of us are aware of the Hurricane Maria that went through Puerto Rico a few years ago, and it wiped out multiple bridges around the country. And a lot of those actually cut off people from access to food and other necessities. And so it was very difficult and important to get these access ways open back up as soon as possible. Once again, this was a US bridge project, and they were able to work with a galvanizer in Ohio, and they had the first modular bridge structures built, galvanized, and shipped down to Puerto Rico within 6 weeks of Hurricane Maria, and all of the bridges were replaced within 6 months of the tragedy. So as I mentioned at the beginning, a lot of the reason to use hot dip galvanizing is for its longevity. And even in the temporary structure, this could become important because sometimes our best laid plans don't work out how we expect. And maybe we thought the bridge was just going in for 5 years, but it could end up being there for 20 or 30 years, depending on the situation. So one of the advantages of using hot dip galvanized steel is that basically you pay for it up front, you put it up, and you can more or less forget about it. So if it's in a remote area that's difficult to access or anything like that, you really don't have to worry too much about maintenance or closing it down. This particular time to first maintenance chart that I'm showing you here shows kind of the life of hot dip galvanized steel in various atmospheric environments. And the typical, I guess the minimum coating requirement for galvanized steel for any piece of steel that's a 1/4 inch thick or greater is about 4 mils of zinc. So if you look at that 4 mil line and come up and look at, even in an industrial environment or an urban area, which is the most corrosive, you're looking at about 72 years before any maintenance is required. And that would be defined as 5% rust of the steel surface. So 95% of that bridge would still have some zinc coating on it at that point. Here's an example that actually is current from this year. This is an acro structure. It's 230 feet long. And the former bridge here was actually damaged in May of 2020 by some historic flooding in the area. And so they really didn't have a lot of choice. The area was closed off to traffic and they needed to come up with a solution quickly. So they worked with this modular structure to make a detour until they could decide if they needed to put in some other sort of permanent structure. So it was, construction began on December 1st, and I believe the bridge opened in February to traffic in the area. So once again, quickly able to put this modular structure together, put it up, and get traffic moving once again. Speaking with a group of folks that are involved in the forestry service, I know that sustainability is an important part of what you do and what you consider every day. And so one of the things that I like to talk about with galvanized steel is the environmental advantages that it provides. And one of the biggest things, or the thing that I like to start with, is that galvanized steel is made of natural and abundant materials that are essential to life. So zinc is the 24th most abundant element in Earth's crust, and iron ore is the 4th. So they're readily available to us and able to be used for this type of construction. But more importantly than that, they're both 100% recyclable without the loss of any properties. So you can basically use steel and zinc over and over again as steel and zinc, or a hot dip galvanized piece could virtually become a hot dip galvanized piece over and over again. And in addition to the ability to be able to do this, I think it's important to highlight the fact that it's not just something that's possible, but something that's done as a standard of practice. Steel is one of the most recycled materials in the world, and the reclamation rate of zinc is 80%. So 80% of all zinc that's available for recycling is actually reclaimed and put back into service. So I think it's something that shows that not just lip service, but this is something that we actually do in our industry. In addition to those two major environmental items, of course, that maintenance-free longevity that we just talked about also is a great thing for sustainability, because there's no VOCs or emissions or anything coming off of that bridge while it's in place. There's no maintenance, so there's no need to bring out vehicles or other things to come out there and disturb the environment while it's in place. If you wanted to get an idea of the life cycle of hot dip galvanizing, this is basically just an abbreviated version or abbreviated chart that shows you what you get. But basically, again, as I've mentioned, all of the raw material and energy input, or the environmental impact, if you will, is really isolated in the production of the bridge. When it's in use, there's usually no input for maintenance, no emissions coming out of it. It can just be out there for 75 or more years. In particularly in a rural environment for easily 100 years, a little bit of energy when you want to demolish the bridge or take it down, but otherwise it's just going to sit there and kind of do its job. And when you take it down, of course, 100% recycle, loop back into production, no waste of materials there. So I talked earlier about the Indian Mill Bridge, which was basically deconstructing and reconstructing a existing steel structure. This is a very similar type of project where all the bridge rails on this road in Michigan, which is also more famously known as 8 Mile Road, were removed after over 50 years of service. They were able to strip off the existing galvanized coating that still remained, re-galvanize them, and put them back in service. And the Michigan DOT only had to use 20% new material in the entire project, which was the addition of the second horizontal rail that you see here. The previous version only had one horizontal rail. And the only panels that had to be replaced were due to vehicle damage and not to corrosion. So just a great example of being able to reuse steel over and over again for new structures. And then finally, there's a lot of versatility with hot dip galvanizing. First, it's important to understand that it's a factory controlled process that can be done 24/7, 365. There's fabricators located throughout North America ready to help service this and provide the coating. No really, issue with turnaround time. We don't have to worry about, temperature, humidity, or anything. We can just produce, as I mentioned. We talked about the abundant materials. It also provides some efficiency and safety, just as steel would in any case, but you can do what I would call more with less, which basically the strength to weight ratio of steel allows for you to span a longer length without a vertical column, things like that. So it really provides that design flexibility for intricate areas that are needed for or intricate areas where you're trying to build a bridge. The other thing that is kind of important to think about is it's a stockable inventory. You could stock common parts like guardrails and things. And if you had one damage or had to be taken out, you can have another one ready to just go right back up in its place. But one of the best examples of galvanizing versatility is the last case study that I want to show you here. And this is kind of a 2-for-1, if you will. So this is the former Four River Bridge in Quincy, Massachusetts, that was put in 2002. The existing Four River Bridge had some serious damage and I believe was actually closed to traffic because of the damage, or they needed to close it down because it was not safe anymore or couldn't pass inspection. But of course, this is a common byway and it was very necessary to have the connection there. So they use an acro structure again to put up a temporary bridge to bypass this area until the permanent structure could be constructed. And this was in place for about 15 years. So it gives you an idea of how long it took them to decide on a path forward, demolish the existing bridge and build the new. And if it weren't for this temporary structure, that would have been a very difficult 15 years for the folks in the area. But what's even more impressive about this particular structure is that in 2019, when this bridge was no longer needed and was going to be deconstructed, Jay Cashman, which their headquarters is right next to the edge of this bridge, basically decided to take all of the steel, instead of having it trashed or recycled or demolished. They actually took all of the steel pieces that you see here, brought them onto their yard next to the bridge, and are now reusing the steel to build bridges for underserved communities free of charge. So let's take a look at this video that shows where the new life of part of this Four River Bridge is now. See if my video will queue up for you here.
My name is Jay Cashman. I'm the chairman of the board of Cashman Companies, located here in Quincy, Massachusetts. The company was started by myself in about 1970 when I was in high school. Over the years, we built it into a multidisciplined, heavy civil, marine, dredging. We had basically done the demolition on the Four River Bridge project, and there had been a acro bridge there for many years. So we had the demolition contract to take down the temporary structure and the remnants of the former bridge. The project was actually next to our headquarters. I kept looking at this bridge, and I said to myself, we have to find some sort of repurpose for it. It had been scheduled in our estimate to just demolish it and send it to the junkyard and to get the value of the junk. It was amazing, big, very heavily trafficked bridges were made of these structures, which I had like 2 miles of. And I think it takes a lot of courage to actually get down there and get your hands dirty, which, going down to Haiti and seeing people in poverty, and maybe an abject poverty, as greater poverty I've ever seen in the world. And I said to myself, okay, maybe this is what I'm supposed to do. So off we went.
My name is Liz Turchia. I'm a project manager at J. Cashman Inc., and I am the co-director of the Cashman Family Foundation. They came into possession of all of this several thousand linear feet of acro bridge, and in deciding what to do with it, we thought the best thing to do would not be to scrap it, but to use it again, because it's still totally serviceable. It has a lot of life left. So through our connections and our friends who already do work in Haiti, we got connected to some parties down there that are interested in infrastructure development, and helped us to sort of develop the concept that became the Cashman Family Foundation.
We're really kind of looking for places that'll never end up getting any attention. That's kind of my goal at this point, is like Purge. That was on nobody's radar, and Liz found that opportunity. They've helped me navigate the social, economic, political dynamic of Haiti, which is, let's just say, it's complicated. At the very least, it's really complicated. Nobody's ever going to help these people, and this is something that I can really feel that we accomplished something. One of the compelling reasons to promote this program or to keep these bridge sections as they were was the fact that they were galvanized. Even after 20 years, there's very little lamination, there's very little oxidation that's taken place. The galvanizing stuck on it. Whoever did the job did a really good job. These bridges, they're just as good as they once were. Generally speaking, I think that they're in excellent condition. It's amazing. I'm familiar with galvanizing from back in the 60s when I first started building bridges, and everything had to be hot dip galvanized, and it wasn't that way before. And piers and all the bolts that we had were galvanized. We can go back to projects that we did decades ago, and you could still back those bolts off. And the fact that if I was concerned about that galvanizing, I would have basically just sandblasted and repainted it. Okay, I'll re-galvanize it, whatever, but the galvanizing was good. I think that they'll get another 30, 40 years out of this thing without really much in the way of maintenance at all down there. My experience with galvanizing, over the years, particularly around marine structures, and it really kind of changed the world.
So that's kind of the end of my presentation. I like to finish it off with that video because I think it really shows the opportunities for temporary structures and the reuse of galvanized steel. So even if you were to put in a structure that you only needed for a few years, if you build with these modular structures that many of the manufacturers of the Short Span Steel Bridge Alliance can provide, it's easy to reuse that in a new location each time that you have a new need. So with that, I'll open it up to any questions that you may have for me.